All right, so I'm going to show you how to work out these questions for the Chapter 4 review for intermediate algebra. First off, let me just say that you're going to have to know how to factor, and I'm not going to show you how to factor on this video. So if you don't know how to do this factoring, you need to go back and review some of the videos from Developmental 2, Chapter 5 for factoring. So first off, we're going to simplify some rational expressions here. To simplify a rational expression, you have to factor the numerator and the denominator. So the numerator says 4x minus 6. We're going to factor out a GCF of 2 in the numerator. So that will be 2 times 2x minus 3. And there's a GCF in the denominator of 2x. So we're going to factor out a 2x. So 2x times 2x minus 3. Now the idea with rational expressions is to factor so that we can cancel the factors that match. And you can see this 2x minus 3 matches. So we're going to cancel them off. And our final, actually we can cancel off these 2's because they match also. Our final answer is 1 over x. On number 2, the same idea. We're going to factor the numerator and the denominator. In the numerator, you're going to have to use either the AC method or line divide or the Columbian method to factor this trinomial because of this 2 here. But after you do all that, you're going to have factors of 2x plus 1 times x minus 1. And the denominator is the difference of squares. So when we factor that, we'll have x plus 1, x minus 1. And again, canceling the factors that match, the x minus 1, we're left with a final answer of, I'm going to slide over here, 2x plus 1 over x plus 1. And please remember that once you get to this point, you cannot cancel these factors because they're not factors, they're terms. You can't cancel terms. If it didn't cancel back here when you have the factors laid out because they're not the same, you won't be able to cancel these terms over here. So this is your final answer for number 2. In number 3, again, factoring the numerator, there's a GCF of 2. So we'll take out a 2 and we'll have 6 minus x. The denominator is the difference of squares again. So x plus 6, x minus 6. Remember, you can cancel the x minus 6's and the 6 minus x, but they're not exactly the same. They're opposites. So if you cancel these, you have to remember to replace them with a negative 1, and we always put that in the numerator. So what you have left here is 2 times negative 1 in the numerator, negative 2, over x minus 6 in the denominator. For number 4, you might at first think that you need to use AC on this trinomial because of this 2 here, but if you look, the 2 is actually a GCF. So factor out 2 as GCF, and you're left with y squared minus 3y plus 9, which is a standard trinomial. However, it's not going to factor because there are no factors of 9 that add to make 3. So then in the denominator, you also have a GCF of 2. So when you factor out the 2, you're left with y cubed plus 27, which is the difference of cubes, or the sum of cubes, I'm sorry. So for the sum of cubes, remember we have that formula where we assign a as the cubed root of the first term. So a is going to be y. B is the cubed root of the second term, so b is going to be 3. Here's our GCF here. So we have a minus b, a plus b, I'm sorry, it's a plus, y plus 3 times y squared minus 3y plus 9. And then you can see that these trinomials actually match, so they are going to cancel themselves off just like that. And the 2's cancel off, and we're left with y plus 3, but it's in the denominator. So don't make the mistake of saying the answer is y plus 3. You can't lose the numerator. The numerator actually has a 1 in it here, so the answer is 1 over y plus 3. All right, for number 5, we're finding the domain. The domain of a rational function, remember, is all about the denominator cannot equal 0. So we have to figure out what values would make this equal 0, because those will be excluded from the domain of a rational function. So the first thing we're going to do is we're going to take this trinomial here, and we're going to factor it. So the factors of this trinomial will be x plus 1 times x plus 1. And then because it's all about the denominator, you take those factors and you set them not equal to 0, because that's what we want. Since they're the same, we only really have to do it once. What we know is x plus 1 cannot equal 0. So isolating the x, we get x cannot equal negative 1. We're going to write that in set builder and in interval notation. So our set builder will look like this: x such that x cannot equal negative 1. And our interval notation, if you remember, this negative 1 is the only value that x cannot be. X can be all real numbers except negative 1. So if we were to draw a number line, there would be a hole at negative 1. So when we do interval notation, we're saying that we can have everything from negative infinity to negative 1 unioned with negative 1 to positive infinity. And of course, using the parentheses here is telling us that everything is included except that negative 1. All right, we're going to do domain again on number 6. So we need to factor this denominator, which is the difference of squares. So x plus 3, x minus 3. And that means that x plus 3 cannot equal 0, and x minus 3 cannot equal 0. And when we isolate the x, then we have x cannot equal negative 3, x cannot equal positive 3. So we're going to put that in set builder, x such that x cannot equal negative 3 comma positive 3. And we always write these in numerical order here. So negative 3, then positive 3. And in interval notation, if you remember, now we have 2 holes in our interval. So that means we have to have 3 intervals joined with the union. So first, negative infinity to negative 3, union with negative 3 to positive 3, union with positive 3 to positive infinity. That's our interval notation. All right, in number 7, we're going to evaluate a function. The function is f of x equals x over x minus 2 for f equals 0, f equals 1, f equals 2, and find f when f of x equals 5. All right, I'm just going to scroll up so we have some white space here. All right, this is evaluating the function. So if you're finding what the function value is, all you need to do here is substitute these values for x and simplify. Now this part's a little bit different because it's telling you that f of x equals 5, so the 5 will be going over here. But let's do these 3 parts first. So f of 0 will be this same function, but the 0 is substituted for x. So 0 over 0 minus 2 equals 0 over negative 2, which equals 0. F of 1 will be 1 over 1 minus 2, or 1 over negative 1, which is negative 1. F of 2 will be 2 over 2 minus 2, which is 2 over 0, which is not 0, it's undefined, with a 0 in the denominator. Now, this last part, find x when f of x equals 5, means we're going to replace the f of x with 5. So 5 equals x over x minus 2, and we have to solve for x this time. If you remember, you can write this 5 as 5 over 1, and you can actually do this like a proportion. 5 over 1 equals x over x minus 2, and then these cross products will be equal. So if we do that, then we have 5 times x minus 2 equals x, and we just simplify. 5x minus 10 equals x. I'm just going to carry this over here, guys. 5x minus 10 equals x. Put all the x's to the same side, so subtract this 5x. We get negative 10 equals negative 4x. Divide by negative 4, we get positive 10 over 4, which reduces to make positive 5 over 2 equals x. And that's your value for x then.